Hi, everyone. Welcome to the latest in Beacon's webinar series. Today, we're going to be talking about accelerating the path from pre-trade to booking. I'm your host. I'm Mark Higgins. I'm Beacon's Chief Analytics Officer and one of our two co-founders. So today, we're going to be talking about two key challenges that a lot of trading desks face. The first one is where people come up with great ideas in an R&D environment, but that R&D environment is kind of a separate environment, and it takes a long time to get those ideas from R&D into production where people can use them to make money for the company. The second one is one where we've got pre-trade tools that are used by business users that are a different system than the post-trade tools where you actually go and book the deals that you've done and run official valuations and risk and things like that. Some examples of the first challenge, imagine you're a derivatives market making desk and you've got a client who's got some specific views on the market and hedging needs, and you want to design an exotic derivative product to meet those most efficiently. So the usual process here is a quant goes in an R&D environment, represents that payoff, builds some pricing for it, plugs it all together and tests it. But then they have to actually get it from that R&D environment into the production system so people can use it. And often that means handing it off to a separate technology team who maybe completely re-implements it or takes an analytics library and builds applications around it and things like that. And that can take a long time. Second example, maybe you're a quant at a quant hedge fund, and in your R&D environment, you're testing out a whole bunch of ideas for new trading signals, and you finally find one that works. But then to actually get it run in production, you have to hand it off to a different technology team who goes and builds it maybe in a whole different programming language in the production trading system. And again, that can take a long time because the quants and tech people often don't quite speak the same language, and so there's a lot of bureaucracy that accrues at the boundary between those. Or maybe you're a quant at a life insurance company, and in your R&D environment, you've been playing around with ideas for better ways of allocating your portfolio of assets against the different kinds of liabilities that you have. So doing better asset liability management. But once you found something that you think works and that would be better for your business, you have to have a separate team go and re-implement that in the production ALM system, which again can take a long time. Some examples of the second one. So again, pre-trade tools, these are like tools that business users are using to price deals. So maybe you're a derivatives trading desk and you've got spreadsheet-based pre-trade pricing tools where you can structure up new ideas and play around with market inputs and things like that. But that's a different system to your booking system, and so it might use different analytics, or even if it uses the same underlying analytics libraries, it might have different sources for market data, for reference data, for convention information. And so you run into scenarios where like a trader structures up a deal with a client and everyone's happy. The trader thinks they made $30,000 on the deal when they price it up in their pre-trade tool. Then they go and book it and run P&L in the production system, and it shows them losing $10,000. That's because the data is out of sync. Or maybe back to that exotic derivative pricing example, maybe it's relatively easy for quants to deploy a new product from their R&D environment into a pre-trade spreadsheet pricing tool. So now you've got a trader who can structure up a new deal in a spreadsheet, then they do a trade with a client, but now they can't book it properly in the booking system because it takes a lot longer to roll out in the official booking system. So they either have to book it approximately and have a bunch of sort of on the side controls to true up valuations because the approximate booking doesn't give the right valuations or risks. Another point is around data quality. So in production systems, there's often really strong controls on data quality. There might be whole teams of people whose job it is to validate the production market and reference data and clean it up and stuff like that, because it's used for the official profit and loss calculations. It's approved for it's used for feeding into the earnings of the company. R&D and pre-trade environments often don't have access to that same production data, and so those pre-trade analyses can be run against noisier or even incorrect data. By the way, as we're going through this, if you do have any questions as we go along, please post your questions in the chat and we'll get to them at the end of the presentation. So why does this stuff happen? First reason, quants, data scientists, financial engineers, that sort of category of developer, they're really good at solving business problems as they come up using analytics and data, But what they often aren't as focused on is enterprise technology skills. And by that, I mean things like, corralling giant amounts of data or working effectively with big teams of developers, satisfying all the technology controls that modern institutions have. It's just a different skill set and they often don't really know it. But what that means is they're generally not allowed to change the production systems themselves. Quants still want to get stuff done though, without waiting on the technology people. So often they'll create their own like R&D technology stack. Sometimes a tech team will help them do that. But what that leads to is kind of siloed teams, siloed technology stacks that are built for rational reasons when people first come up with them, but in the sort of medium and long term lead to long delays on deploying new ideas out to the business and end up kind of stifling innovation sometimes. Another reason it happens is that our industry is heavily regulated, especially on the sell side, but also on the buy side. And those regulations impose a lot of controls on how technology changes are made, how the production environment is run, and that sort of thing. And even worse, financial institutions are often incentivized to interpret those regulations really conservatively. The regulations that we have to live with are really complicated, and only a small number of people at any company kind of really know what they are. And then they'll work with the broader control teams to interpret what they've heard, define internal standards, and then they pass those off to the rest of the company, to technology teams and businesses, who then kind of reinterpret what they get. And generally, they get more conservative at each step of this process, and that's due to incentives. There's generally very little upside in being aggressive to interpreting the regulations. And it'd be great if you can actually be kind of aggressive while still satisfying the constraints. It can help your business a lot. But if you don't have the technology tools to do it, then you generally don't get that much juice out of being aggressive. And there's very little downside in being conservative. No one's ever been fired for being conservative in interpreting regulatory constraints. So what that leads to is a system that has a lot of bureaucracy around these regulatory controls. I've seen, in my career, lots of times where there'll be like a once a month release process, and the release will be big with tons of stuff in it. It's really hard to test. Because of this kind of conservative approach in interpreting the regulations, a lot of people end up having to sign off on it. Dozens of people sometimes end up having to sign off on this change, just because at some point someone was like, that person should sign off on it just as a sort of cover your butt thing. And maybe only a couple of those people actually know what the changes are, but tons of people have to sign off on it, and that leads to a lot of delays in getting functionality into production. Another reason, related to this idea that quants have a kind of a different skill set than the technology people, the quants and technology department tend to optimize for different things. Quants want to optimize for flexibility. They want to experiment with lots of different ideas until they find one that works. Whereas the technology team is responsible for running this really complex production machine that has to perform to exacting standards. So they're generally optimizing for reliability and performance. And those are pretty different optimizations, that flexibility and reliability and performance thing. So it's not really surprising that it's difficult to make everyone happy with one platform. So how do you make it better? Well, not surprisingly, we've got some pretty strong views on how to approach this at Beacon, since that's like the core mission of our company, to make technology at financial institutions more integrated and productive. So we'll be walking through a few examples that touch on these two main points. The first one is that your pre-trade environment, your pre-trade technology stack should be the same system as the production trading system. You shouldn't have this kind of dichotomy. And also the R&D environment should include enterprise technology tools, because that means that the developers who work in it don't have to be themselves experts at enterprise technology. So we're now going to walk through a few examples of how we think about doing this at Beacon, so you can get a little bit more color and depth. So the first thing I want to talk about is integrating data between your R&D environment and your production environment. Ideally, those should be the same system, so that you're using the same data for doing your research as you are for running your production business. So let's jump to an application example for that. Here's an example. This is our strategy backtesting tool. This is a tool for backtesting rules-based trading strategies, trading derivatives. So this particular one here is selling short-dated implied volatility skew in the Russell Equity Index. Building a backtester for derivatives is a fair bit more complex than building a backtester for cash instruments like equities or futures, because for cash instruments, the price of the thing is just the price on the screen. It's kind of comes straight in from market data, and so those backtests often end up just being kind of straight time series analysis. For derivatives, though, you need to pull in that whole complex derivatives pricing and risk management machinery into the mix, which depends on much broader set of market data and reference data. This particular example is a daily trading example. So it uses end of day market data every day, and it says it trades at the end of each day against the end of day closing data. So it depends on end of day data. And one advantage in Beacon or a system like this is where the data that this backtest is running against are the same end of day closes that are used by the business to calculate their official P&L and risk and things like that. So it has the advantage of those teams of people whose job it is to validate that data and make sure it's good. And now you have this really solid history that you can use for backtesting and trust that the data is going to be realistic. Second example, I want to talk a little bit about software lifecycle. So software lifecycle, sometimes this is called SDLC, software development lifecycle. This is the process where you've got some changes that you made in your development environment and you want to get them into the production system somehow. So it's sort of that workflow of how that happens. And in a lot of places, that workflow is pretty manual. And because it's manual, obviously there's a lot of humans involved who have to do a lot of sort of cross checks and controls to make sure that all the controls that people say you should satisfy are actually satisfied. What we think is a better way to do this is to have those SDLC tools be automated workflow tools that are built into your R&D platform. That does a few things. First of all, it forces developers to satisfy all the controls. They don't have to remember which controls to satisfy. You don't have to have a human kind of validating that all the controls are satisfied. The technology platform requires it. That means they don't have to be experts in it as well. So whatever testing needs to happen, it happens automatically. Whatever sign-offs need to happen for whatever particular bits of code you're working on, those are automatically identified and those sign-offs are tracked and auditable and things like that. But once you have that like automated SDLC workflow that's really efficient, what it lets you do is change your whole approach to releases, right? A lot of people think about releases as, you know, infrequent monolithic releases, once every 2 weeks or once a month or whatever, and you have a release with a whole bunch of different functionality in it. And so testing it is complicated, reviewing it is complicated, rolling it back is complicated if something goes wrong. Instead, what we prefer with Beacon is a model where you have lots of little atomic releases that happen all the time. So every change you make is a relatively small change, and you can make lots of them. You know, across your business, you might have, you know, dozens of these things happening every single day. What it means when you have atomic changes is that you can roll them out quickly. You can roll them back easily because they have limited scope, each one. Or you can even just roll out a fix for it if there's an issue. So it lets you be a lot more nimble. And that's a really big deal when you're working on a trading desk. The business users on trading desks generally aren't really good at coming up with crisp requirements. And so generally the way things work is someone says, I'd like this, you build a version 1, they look at it, they give feedback, you build a version 2, and you keep on going through that iteration cycle until you get something good. And you want to have that each step of that iteration cycle be as short as possible. And this control model lets you do that, and it's because it automates this SDLC process. So let's look at an example of that. Here I'm going to go to our IDE, our integrated development environment. That's the place where in Beacon people do development. So it looks like a lot of IDEs in that there's, you know, an area where you can edit source code. There's a terminal window here where you can access the data environment and, you know, interact with high-level objects and do really interesting things plugged into the production data environment. But on the left here is some stuff that has to do with the release workflow. So here I'm looking at a change that I've been playing around with in my development environment. So I did a bunch of work on this deep hedging thing, which is some machine learning thing that we're working on. Here I've created a feature branch. That's a sort of segregated bit in our version control system that has just the changes that I'm working on that haven't been deployed yet. I can see what I've changed here. So here I've got one committed change. I can click on it and it shows me my kind of trivial change that I'm making to this thing. And then I can create a review for this. And so if I go and look at the review, here's a summary of the review. And so I can go and look at, again, what my changes were. I can see what automated testing has happened. So in this case, it had a problem with the automated test run. So I can go and investigate that later. It did a lint check to make sure that my code is formatted correctly. And then up at the top, it shows the list of reviewers. These are people who are allowed to sign off on my change based on the content of my change. So if I go back to the IDE, here it shows me, here's a problem with that test run, so I can go and figure out what that was and solve it. Once I have, then I can get someone to go and review my change from that list of reviewers and sign off on it. And once that's happened, once I've satisfied all the controls for this atomic change, then there'll be a little button here that says deploy. And I can click it and it'll deploy it to production whenever I think that makes sense for deploying it out to my business. So this is sort of how we approach this SDLC process in Beacon in a way that enables this kind of nimble atomic release process. The third example I wanted to talk about was pre-trade tools and post-trade tools being in the same system. Like we were talking about before, if they're not, then you run into issues where the analytics might be different, or the market data that you plug into your analytics is different, or the massive reams of reference data that you need to get right for pricing and managing derivatives, conventional logic, that sort of stuff. If any of those are different, then you can end up with problems between your pre-trade and post-trade systems. So let's go and look at how we do that in Beacon. So here is our Beacon quote tool. This is a tool for structuring up portfolios of derivatives. So here I've got an S&P call spread, 7th of January expiration, 45.15, 48.15 call spread. And it lets me do little things like I can go and plot out the price of this portfolio as a function of the equity price. I can go and run risk reports on this guy. So here I'll run an equity risk ladder. This is a report that's going to show me my headline risk numbers, both at the current market and under a bunch of scenarios. So 0% here corresponds to the current market. It shows me my delta, gamma, vega, and theta. And then I can see how those change as the Russell Equity Index moves around. I can also go and see the market data that I'm using for this. So here's all the input market data and viewers for equities and rates. I can choose different sets of data to use. So we have named sets of data in Beacon, so you can have different regional closes or different close for front office versus middle office and that kind of thing. And I can also connect to intraday data here. So if I click this, it'll take a snapshot from the platform's real-time market data feed, and that's the same for all the different applications that run on the platform. For example, maybe I structure up this deal, price it, agree a price with my client, and go and book it, and then it lands in the booking system, and then it might show up in an application like this one. This is a post-trade tool, so this is running risk on an existing portfolio, and it's showing me some sort of headline risk numbers, and it's showing me a P&L, and this P&L is running off of intraday data, as new real-time market data come in and as new trades come in. But it's using the exact same data environment, for intraday data and for end-of-day data as the pre-trade tools, and it's using the same underlying representations of all those different financial instruments, those equity options in that example. It's using the same representation for all that stuff and all the same data inputs because it's the same system. And by the way, we've been looking at a bunch of equity examples here. Beacon supports, all different major asset classes. It's not just an equity system, but we've been, just looking at some equities examples to keep things consistent. So next example I wanted to talk about are application frameworks. So the idea here is, imagine you're a quant or a data scientist and you've come up with some interesting analysis. Now you want to put it in the hands of the business users. Generally, that kind of developer isn't very good at UI stuff. And so absent anything else, they'd have to hand it off to their peers in the technology department to wrap up in an application to deploy to production and do the enterprise technology bits. And that can be inefficient for the reasons that we've been talking about before. So it's much better to have a framework where non-UI experts can still build simple applications. So let's go back to an example of that, back to that backtesting application, right? So this is a web application. It's an enterprise web application, which means it needs to do a lot of complicated things. For example, it needs to check that I'm entitled to run it. It needs to encrypt communications between the front end that's running in this browser here and the back end that's running on some computer or somewhere in the cloud. Also, there has to be a back-end process for it to run against somehow. And that's all this kind of web application stuff. Plus, it's a web application, which means that it's written in JavaScript and HTML, which, I'm a quant, I don't know any of that stuff. But in Beacon, we have an application framework that lets me script out this user interface as a grid of widgets, right? So I've got like a plot and a table of data, some date pickers, a button that says go. So let's look at the code that I used to generate that. It's Python. In Beacon, a lot of the code that we write is Python code. And so here's the specification for that user interface as a grid of widgets, and this sort of a nested set of containers to define that grid. Here's the plot that shows the performance. Here's the spreadsheet grid widget that shows the statistics. Here's date pickers. Here's the button that says go, and when it runs, it calls some function. Like I can write this as a quant. There's no HTML in here or anything like that. And then I can go and run this application from the IDE, and it goes and opens the application and converts on the fly all that stuff from Python code into JavaScript code. And deals with all the hard enterprise web application stuff. So I don't need to do that. And what it means is that as a quant, I can go and wrap up my analytics with applications all on my own. So now we've got the quant team building their vertical through the stack, their peers in technology building their slices through the stack, all kind of working side by side without having the tech people kind of be in the way of the quant people in their path to production. The last one I wanted to talk about is model risk management. So the model risk team is a group that validates the pricing and risk analytics put together by the quants in the front office of businesses. Before the 2008 credit crisis, that was done kind of asynchronously in the sense that the quants would come up with some new pricing model, and they would go and get that deployed into production, and people would start pricing deals and booking deals and managing risk using those analytics. And then separately, in parallel, the model risk team would go and kind of evaluate and review those analytics. After the crisis, that model risk function became a lot more central and got put kind of in the pipeline to production. So now instead of being asynchronous, it's one step that you have to do before you're allowed to get your stuff into production, which again can slow down that path to production pretty significantly. Often model risk teams are separate organizations. They have their own yet different technology platform, right? A different R&D environment, different even than the R&D environment used by the front office. They have their own set of data that they use. They often don't even have access to the code from the front office, let alone the data. One of the things that they do, for example, is the quants will say, here's a new exotic derivative product. I want to use this pricing routine for it. The model risk people might go and build their own implementation of maybe that model or a different model that they think is kind of comparable so that they can compare their own independent results with what they got from the front office. And you can imagine how complicated and difficult that is to first build and then do that comparison if you're working in a completely different platform. So we think it makes a lot of sense to have the model risk team work in the same platform that the front office quants work in. That way they have access to all the same high quality validated production data to run their stuff against. They have access to the code from the front office people. They have access to the whole same suite of tools that the front office quants do. And they can also do things like run real production tests. So, in Beacon, we make it easy to for a given financial instrument toggle between different pricing routines. So if the model risk people have built their own independent pricing, they can just toggle it so that the real production portfolio uses that and can do real, proper independent review. And then the second part of the model reviewer's job after they've done a review is to do the sign off. And again, if they're working in an entirely different system, that can often be really bureaucratic and manual and take a long time to happen. In Beacon, what we think is the right thing to do is that model reviewers are just another group of people who has to sign off on reviews for pricing and risk changes. So all that same automated tools for doing software deployments that we saw before, the model risk people can leverage just by being one group of people that has to sign off on a change to pricing and risk code before it goes out. So that forces the business to satisfy their model policies and that they have to have model review done, and they can do it auditably and automated and reduce that time to production. So in summary, you often see separate R&D systems, pre-trade systems, post-trade systems, and they're often generated for good reasons, but they're a kind of long-term trap for the business that means in the end, it takes a long time to get new functionality into production and can stifle innovation in a business. Integrating them into a single platform means you can deploy that new functionality end-to-end all the way into the business much more effectively and productively. So that's all we wanted to talk about. Happy to take any questions now. If you do have questions, you can post them in the chat. All right, one question we got. Does this mean that people won't use Excel? It's a great question. Excel's used all over the place on the street, sometimes well and sometimes poorly in a way that makes it hard to maintain. And so this doesn't necessarily mean no one uses Excel. Excel can be a really good front end, as kind of a flexible, configurable user interface. But you really want the calculations in the back end to be done inside a common platform. All right, another question. Is it really possible to have that quicker release cycle in a modern bank? It seems too impossible. Great question. It's already been done. So, it's done at Goldman, JP Morgan, and Bank of America, which are the banks that my co-founder and I worked at before we started Beacon. And it's being done with a bunch of current Beacon clients as well. I remember when I started at JP Morgan and we came in and we said, we'd like to build a technology platform that does this kind of quick iterative releases. They just didn't believe it would be possible. And it took us a year or so of kind of working with the control functions to show them how to do it while we were also, kind of building it in the first place. So it is definitely possible to do in a way that satisfies modern technology constraints in big international banks. Any other questions from the audience? All right, looks like not. So why don't we close it out here, and just like to say thank you everyone for joining and taking the time to listen, and hope we'll be talking to you soon. Goodbye.